Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0223, indicates a high voltage issue within the Throttle Position TP sensor B circuit. This error occurs when the signal voltage received from TP sensor B exceeds normal operating parameters, specifically going above 4.8 volts. The TP sensor is critical for determining the throttle's position, which directly impacts engine timing, fuel delivery, and overall performance. Located at the throttle body assembly, this sensor provides vital inputs to the powertrain control module, PCM, enabling it to adjust engine operations for optimal performance and efficiency. The P0223 fault can lead to significant engine performance issues, including reduced efficiency and drivability concerns. This presentation will guide you through a detailed troubleshooting process for addressing this specific DTC in Honda Civics manufactured between 2016 and 2021. DTC P0223 signifies that the throttle position TP sensor B circuit is exhibiting high voltage conditions. This circuit plays a pivotal role in relaying the throttle's position back to the powertrain control module, PCM, which is responsible for managing engine performance. In this scenario, a voltage reading above 4.8 volts indicates an anomaly that requires immediate attention. The TP sensor's location at the throttle body is critical because the throttle's position influences the air-fuel mixture entering the engine. If this information is distorted, the PCM may incorrectly adjust fuel delivery, leading to performance issues. Hence, understanding the implications of P0223 is crucial for proper vehicle functionality and driver safety. Several factors may lead to the activation of DTC P0223. A faulty TP sensor B may cause erroneous readings, making it appear that the sensor is sending inappropriate voltage back to the PCM. An open circuit in the wiring, particularly in the lines connecting the sensor to the PCM, can also result in high voltage readings. This could be due to damaged wires or faulty connectors that interrupt the signal flow. Furthermore, loose or corroded connections at the throttle body or PCM can contribute to unreliable signal transmission. Each of these potential causes must be closely examined during troubleshooting to pinpoint the source of the high voltage error. Several factors may lead to the activation of DTC P0223. A faulty TP sensor B can cause erroneous readings, making it appear that the sensor is sending inappropriate voltage back to the PCM. An open circuit in the wiring, particularly in the lines connecting the sensor to the PCM, can also result in high voltage readings. Furthermore, once the DTC P0223 has been examined, each of these potential causes must be closely examined to pinpoint the source of the high voltage error. Each of these potential causes must be closely examined to pinpoint the source of the high voltage error. Other potential causes may contribute to unreliable signal transmission. Each of these potential causes must be closely examined to pinpoint the source of the high voltage error. The presence of DTC P0223 manifests through several symptoms that can affect the overall performance of the vehicle. Drivers may notice engine performance issues, including stalling or an unresponsive throttle when accelerating. The high voltage reading may result in a lean or rich fuel mixture, decreasing fuel efficiency significantly. Additionally, the check engine light on the dashboard will illuminate, signaling a problem within the engine management system. These symptoms serve as important indicators that a thorough diagnostic process is necessary to restore normal vehicle operation. Recognizing these signs early can prevent further damage to the engine and its components. The first step in troubleshooting DTC P0223 involves turning the vehicle's ignition to the on mode, which powers up the vehicle systems without starting the engine. This preliminary action allows the technician to access the vehicle's diagnostic functions. Next, using the Honda Diagnostic System, HDS, the DTC must be cleared to reset any stored fault information. After clearing the DTC, the technician should check the parameters for TP sensor B. It is imperative to verify the voltage readings, ensuring they are below 4.8 volts. If the readings do exceed this threshold, it confirms a persistent issue, enabling the technician to move forward with further diagnostic steps to isolate the exact cause of the problem. The second troubleshooting step requires the technician to use the HDS to check for any pending or confirmed DTCs. Specifically, the focus should be on observing whether both P0123 and P0223 are indicated at the same time. P0123 refers to a similar issue in the TP sensor A circuit. If both codes are present concurrently, this suggests a broader issue affecting the throttle position system. In this case, the technician is directed to proceed to step 5 for further investigation. Alternatively, if only DTC P0223 is confirmed, the technician will continue with the next diagnostic step to narrow down the failure area specifically linked to TP sensor B. Clear identification of all present fault codes is critical for effective troubleshooting. In step 3, the vehicle should be turned to the off mode, providing a safe working environment for the technician. The next task is to disconnect the throttle body 6P connector, which isolates the throttle position sensor from the vehicle's electrical system. Following disconnection, turn the vehicle to the on mode again to energize the circuits. The next vital step involves measuring the voltage between two test points, the throttle body connector's number 4, terminal and body ground. The expected measurement should be around 5.0 volts. If this voltage is confirmed, it indicates that the throttle body is faulty and needs replacement. If not, the technician should then proceed to the subsequent step for deeper investigation into the issue. The fourth step in the troubleshooting process is to check for continuity in the THL2 line, which connects the throttle body to the PCM. Begin by ensuring the vehicle is in the off mode. Then, jump the SCS line with the HDS to create a short circuit, ensuring the system is properly prepared for testing. Disconnect the PCM connector E, 80P, allowing for an accurate continuity check. Measure the continuity between the throttle body 6P connector number 4 and PCM connector E number 51. If continuity exists, it confirms that the THL2 wire is functioning correctly. If there is no continuity, it indicates an open circuit in the THL2 wiring, requiring repair to restore proper electrical connections. The fifth and final troubleshooting step involves checking the open wire condition in the SG3 line. Begin by turning the vehicle to the off mode, then create a short in the SCS line with the HDS. Disconnect both the throttle body 6P connector and the PCM connector E, 80P, to separate all electrical connections. The technician should then measure continuity between throttle body connector number 3 and PCM connector E number 76. Successful continuity indicates that the SG3 wire is intact. Conversely, if continuity is not found, it points to an open circuit along that wire, necessitating a repair to re-establish a solid electrical connection critical for accurate sensor readings. After completing the necessary repairs, it's crucial to verify that all diagnostic trouble codes, including DTC P0223, have been cleared effectively. This can be done using the HDS to scan for any remaining faults. Following the clearance, a test drive is essential to ensure the vehicle is operating as intended and to confirm that no further performance issues arise related to the throttle position sensor. Ensure that during the test drive, the check engine light does not reappear, signaling that the issue has been successfully resolved. Observing the vehicle's performance metrics can also help ensure a smooth operation without symptoms associated with throttle position errors. This final verification step is paramount for confirming that everything is functioning optimally before returning the vehicle to service. Preventive maintenance plays a significant role in avoiding issues like DTC P0223 in the future. Technicians should conduct regular inspections of the wiring connected to the throttle body and the PCM. It's critical to address any signs of wear, corrosion, or damage to connectors that could lead to signal disruptions. Additionally, monitoring the vehicle's throttle performance ensures that any fluctuations or abnormal behavior can be detected early. Implementing early detection strategies, such as periodic diagnostic scans, can also help pinpoint potential problems before they trigger a DTC. By staying ahead of possible electrical or sensor-related issues, vehicle longevity and performance can be significantly improved, leading to a safer driving experience. In conclusion, DTC P0223 is indicative of a high-voltage scenario within the TP sensor B circuit, signaling potential performance issues that require immediate attention. A systematic approach through thorough troubleshooting is essential to diagnose the root cause of the fault accurately. By following the outlined steps, technicians can isolate the problem effectively, whether it involves sensors, wiring, or connectors. Maintaining an ongoing preventive maintenance plan can further reduce the likelihood of encountering similar issues in the future, ensuring the vehicle remains in optimal working condition. Understanding and addressing these codes not only contributes to vehicle performance, but also enhances safety on the road. Proper diagnostics empower technicians to provide effective solutions, ultimately leading to satisfied customers and reliable vehicle operation. Please like and subscribe to the channel. See you next time.